Hey everyone, welcome to EduKaji. If you're first time here, my name is Walter and I'm a scientist and also a chemistry tutor for the past 8 years. For today's video, we're going to explore SPM trial paper for Selangor, set number 1, and this will be the paper 1 version. So I hope this particular video will be able to help you to do some revision as well as to gain some knowledge in chemistry. So without further ado, let's take a look at the questions together. This is the first question. So for the first question, a student carries out an experiment to determine the rate of dissolving salt at different sizes. Which of the following apparatus is essential for the experiment? So the main equipment or the main apparatus that we actually need to calculate this rate of dissolving. Technically, rate of dissolving means how fast a salt can dissolve inside the water. So if you want to know how fast a salt can dissolve in water, definitely we'll be able to need, we'll be needing a stopwatch, because a stopwatch will be able to allow us to calculate the time taken for the salt to dissolve. Other than that, the rest of it is not really relevant. For number 2, what is the Avogadro constant, or what's the meaning of Avogadro's constant? So Avogadro's constant refers to the number of particles in 1 mole of a substance, which is technically equivalent to 6.02 times 10 in the power 23 particles. Okay, but that is technically for 1 mole of any substance. Okay, so that would be 6.02 times 10 in the power 23 particles, which is also technically known as the Avogadro's constant. Number 3, which of the following substance is an ionic compound? So ionic compounds are technically made up of ions. And in this case, there's only one thing which is made of ions, and the answer is magnesium oxide. All right, magnesium oxide is made up of magnesium ions and also oxide ions, while the rest of the other answers, they're technically made up of molecules. Like for example, this is ethanol, which is made up of ethanol molecules. This is made up of sulfur dioxide molecule. And then we have tetrachloromethane, which is also made up of molecules. So the only ionic substance over here will be number 3. For number 4, which of the following is a factor that affects the rate of reaction? So the answer here will be, of course, if you see all these answers, they may look like as if they are factors that could affect the rate of reaction. However, if we take a look at this, they talk about size, right? Talk about size. They talk about concentration. They talk about presence of the catalyst and temperature, in which most of us will know that, okay, all these factors can actually affect the rate of reaction. However, if we take a closer look, right, what they actually mention here is size of the product, not the reactants, concentration of the product, not the reactants, and the temperature of the product, not the reactants. Now, when we talk about rate of reaction, we normally look into the initial amount of reactants, because the more reactants there are, then there will be a higher rate of reaction because they could collide with each other. Right? The particles of the reactants can actually collide with each other. But in this case, if you talk about product, that will be after the reaction already. So that doesn't count anymore, technically, right? So you have to consider the fact that if you have different sizes, a smaller size of particles for the reactants, concentration of the reactants, temperature of the reactants, then that could be the answer. But in this case, product doesn't actually count. But C is the answer, all right? Because in the presence of a catalyst, it could actually lower down the activation energy, and it could actually increase the rate of reaction. And they actually didn't mention anything about product over here. So therefore, C is the best answer. Number 5, what is the oxidation number of carbon dioxide? Which technically, you may be confused a little bit, because when we talk about oxidation number, usually what happens is that we think about, okay, what's the charge of either of the elements inside the compound, isn't it? But in this case here, the oxidation number of carbon dioxide technically means what's the overall charge of carbon dioxide molecule. So technically speaking, because they have like, both of the atoms, or should I say both the elements already achieve octet in this case by sharing electrons inside the structure. So therefore, there will technically be no charge whatsoever, right? So therefore, I would say that the overall oxidation number, or the overall charge of carbon dioxide, will technically be 0. Let's look at number 6. For number 6, which of the following is true about an endothermic reaction? So an endothermic reaction is a reaction that generally absorbs more heat to break the chemical bonds rather than to release more heat to form new chemical bonds, okay? And because of that, the answer here technically will be donkey, okay? Where you will notice here, they actually describe perfectly what an endothermic reaction is. You see here, heat absorbed to break the bonds is higher than the heat release for the formation of the new chemical bonds. Very simple. For example, you see here, let's talk about generally any endothermic reaction. Okay, I'll give you an example of an unknown substance. So we go A plus B and we get C plus D, for example. So whenever you want to break chemical bonds, I mean, you want to form new bonds, you must first break chemical bonds, right? And let's just say if you have A and B, you must first break the chemical bonds between A and B. All right, so this is bond breakage. And bond breakage technically requires the substance to absorb the heat energy, right, to overcome the chemical bonds that they have first. So once they get rid of that chemical bonding, then they'll be able to reshuffle the atoms to form the new products, the particles of new products. And when they form these new products, of course, there will be bond formation, new bond formation from the atoms. So the process of bond breaking is technically endothermic reaction. And the process of forming new bonds will actually be an exothermic reaction. All right, now if endothermic reaction is greater than exothermic reaction, then generally the whole reaction is actually an endothermic reaction. So therefore, D perfectly describes what an endothermic reaction is, and that is actually true. The rest of it is actually wrong. As you can see over here, A says that the container becomes hot, but we know that if it's an endothermic reaction, the surrounding temperature will drop. So therefore, the container should be becoming cold instead of hot. And the value of delta H is supposed to be a positive sign for endothermic reactions. Negative sign is for exothermic reactions generally. And then for C, the total energy content of the reactants is higher than the products. This is not true, right? For the endothermic reactions, the energy content of the reactant should be lower than the products itself. That's why if you take a look at the energy level diagram for an endothermic reaction, you realize that it is actually an arrow upwards, all right? So this is to prove to you that the reactants will have lesser amount of energy compared to the products, and the delta H value is positive. So therefore, I would say the answer is D. Let's take a look at number 7. So number 7 here says, which of the following is a structural formula of a detergent? Among all of this is supposed to be B, okay? So usually why there will be a salt of a particular metal ion. So you can see here there is sodium ion, and of course this group here, which is very obviously is part of the detergent, right? So we have two sections over here, two parts over here. The first part is technically this one, and the other part is actually the metal ion. In this case, it would be sodium or potassium that's attached to that particular group. So therefore, this will be B. For number 8, diagram 1 says here, diagram 1 shows the standard representation of the symbol of beryllium atom. So what is the number of valence electron in the beryllium atom? So the smaller number is usually referred to as the proton number. And the proton number is also equivalent to the number of electrons. So meaning to say the number of protons and number of electrons is the same for a neutral atom. So if beryllium has 4 electrons, then the electron arrangement of beryllium will be 2-2. All right, this is the electron arrangement of beryllium. So you can see here the outermost shell, which is the valence shell for beryllium, is only 2. Right, so that means beryllium technically has 2 valence electrons. So the answer here will be A. The next question, number 9. Diagram 2 shows the electron arrangement of atom M. All right, which of the following is the position of element M in the periodic table of elements? So there are 2 information that we can get from over here. All right, the number of valence electrons will correspond to the group that the particular element is in. Okay, and another thing is that the period will be referred to the number of electron shell it carries. Right, so just to keep it simple, group is equivalent to number of valence electron that the particular atom has, and period will be referring to the number of electron shells that the particular atom has. So if we look into this atom, you can see that it has technically has 2 valence electron in total, right? 2 valence electron in this case. That means it is actually in group 2. And then for the other one, you can see here, right? There's 3 shells in total. There's 1, there's 2, and then there's 3. So therefore, it is actually in period 3. All right. So therefore, the answer for this particular question will technically be B lah. Okay, group 2 and period 3. Let's look at number 10. For number 10, which pairs of reactants in neutralization reaction? So neutralization reaction is between an acid and a base, and it is usually based on the hydrogen ion and the hydroxide ion to form water molecule. So that's the ionic equation for a neutralization reaction. So you must look into any of those substances that can actually give you hydrogen ion and also hydroxide ion to form water molecules. Okay, so the first one you can see here, right? Sulfuric acid definitely can be an option, because why? Let me just write the chemical equation for you. So for the first one, right, sulfuric acid H2SO4 plus sodium hydroxide, you will technically get sodium sulfate and 2 moles of water. Okay, so water is technically formed from the hydroxide ion and the hydrogen ions. So technically, number 1 is technically correct. Second one, hydrochloric acid reacts with copper 2 oxide. So in this case, copper 2 oxide also can neutralize the hydrochloric acid. But how does it work? So for example, over here, if you have HCl plus CuO, you'll get CuCl2 plus H2O. Again, we actually have water being formed in this case. So okay, now of course you'll be wondering, like, how can the hydrogen ions and the hydroxide ions be produced? So when copper oxide dissolves in water, dissolves in the acid itself, the copper oxide which dissolves in the water inside the hydrochloric acid would generate the hydroxide ions, which will then combine together with the hydrogen ions from the acid to produce the H2O. All right, and of course, the sulfuric acid also is able to produce the H+, okay, and the sodium hydroxide does now also can produce the hydroxide ions. So therefore, these two cannot. But for the rest of it, you can see here, for sulfuric acid is different. Sulfuric acid and calcium carbonate, it cannot, because why? And this is not a neutralization reaction. This is a reaction between a metal carbonate with sulfuric acid. So that's not considered as a neutralization reaction. And for the hydrochloric acid and potassium carbonate also, okay, because technically there's no hydroxide ion and the hydrogen ions combined together in a way. So therefore, the best answer here will be A, 1 and 2. For number 11, the diagram 3 shows the arrangement of atoms in bronze. So we have tin and copper inside there. So what's the function of the tin atom? So tin is actually a foreign atom. It's actually added inside the copper structure. So the best answer to describe what's the function of tin in this alloying process is actually to reduce the layer of copper atoms from sliding easily. This makes the alloy much more durable, much more harder, and less malleable compared to the pure metal itself. So usually when we perform alloying, that's the main purpose of it, is to increase the strength and the hardness of the particular metal. For 12, which of the following is the molecular formula of propanol? So propanol has a formula of C3H 7OH. However, you can see that among all those lists, there's no such thing as H7OH. So what I can do is I can actually convert this into a molecular formula, this normal molecular formula. So if you just combine the H inside the 7, you'll get C3H8O. So the best answer here is actually C. For number 13, diagram 4 shows process X. So what is process X? So you can see here, right? There's a carbon-carbon double bond. Okay, just ignore the benzene ring, because most of us, when we look at the benzene ring, we get panicked a little bit, like, oh, what is this something new that I see over here? It doesn't matter. The main idea is to understand that you have a carbon-carbon double bond that's about to undergo a polymerization process. How do I know this is a polymerization process? Because you see, right, there's a lot of repeated units. It is actually the same unit repeating over and over again. So what's going on over here is that the double bond between the two carbon atoms, all right, in this structure, opens up and accommodate the adjacent molecules of the same type. They'll form a very long chain molecule, all right? And that's why you see over here, there are a lot of it, a lot of this particular structure. So we call this as a polymerization process. To be exact, this is called an addition polymerization because we have a carbon-carbon double bond over there. Let's look at number 14. So for number 14, carbon 12 and carbon 14 are isotopes. What is the similarities do both atoms have? So I'll say the similarities between isotopes, because you see carbon 12 and carbon 14, they're technically the same element, all right? It's just that the reason why one is 12 and one is 14 is because they have different number of neutrons. Isotopes generally have two things, which are, I would say, in common. They have the same number of protons, but they differ in terms of the number of neutrons. They still have the same number of electrons and therefore they have the same chemical properties. Okay, remember, if they have the same number of protons, they technically have the same number of electrons as well. Same number of electrons. So in this case, what happens here is that if you take a look at this, the number of protons should be the same. And you can see here, do they have the same number of neutrons? They do not, so please ignore that. Do they have the same physical properties? No. Why do they not have the same physical properties? It's because the physical properties of the substance depends on things like their mass, their melting point and boiling point, all those things, but they're affected by the type of chemical bonds they can carry out, as well as the movement speed and things like that. So those are called physical properties. They're not the same because they have different mass technically. But chemical properties, yes, they do have the same chemical properties because they do have the same number of electrons. If they have the same number of electrons, they should technically have the same number of valence electrons, because atoms, they tend to react with their valence electrons. They tend to interact with other atoms based on their valence electrons. So therefore, B will be the best answer, 1 and 4. For 15, which characteristic is similar for all elements in group 18 in the periodic table of elements? So group 18 elements are known as the inert gases or the noble gases, okay? And there's only one thing which is in common among all of them, is that because they are unreactive and they have already achieved stability, they all exist as a monoatomic gas, which is a very distinctive feature that only exists in group 18 elements. That is something that you must know. Other gases like hydrogen, oxygen, nitrogen, all those, they technically exist as diatomic gases. But for the periodic table of elements, group 18, there's one specialty about them, is that they can form monoatomic gases. For 16, which of the following is a strong acid? So strong acids, if you recognize them, right, it's actually nitric acid, okay, HNO3. In fact, there's only a few strong acids in your syllabus that you know of. Of course, the first one will be HCl, AQ. And then you have your sulfuric acid, which is also aqueous. And then you got your nitric acid. These are the three main types of strong acid that you have in your syllabus. Formic acid, ethanoic acid, and also carbonic acid. They are all classified as weak acids. So the answer here will be D. For 17, the following information is about substance Z that is used in the bullet train. All right. Conducts electricity with no resistance at low temperature. So what is substance Z? So technically speaking, to use a conductor which conducts electricity with technically no resistance at low temperature, we call them as superconductors. Only superconductors can actually do that, where they can actually conduct electricity at zero resistance, all right, in very low temperature. So the answer is A. 18, diagram 5 shows the structural formula of ethanoic acid. They even number the atoms for you. So which of the following hydrogen atom will be involved in a chemical reaction? So normally, right, you can see this is the ethanoic acid. So you can see here, this is the functional group of ethanoic acid, right? So when any organic acid or any carboxylic acid, when they dissociate in water, what happens is that the hydrogen over here will be the one that is dissociated, or it is actually released to form hydrogen ions. Okay, remember the dissociation equation. You have CH3, COOH, all right, partially dissolving in water and dissociate in water to produce hydrogen ion as well as ethanoic ion, right? So you can see that the hydrogen ion is actually from the edge of the molecule. So it is actually hydrogen number 4 that is going to be released out during chemical reactions and stuff like that. So therefore, the answer will be D. Number 19, when a substance R is added, to latex, the process of coagulation of latex slows down. What is R? So only an alkaline substance can slow down the coagulation process of latex. So among all of this, there's only one alkaline substance, which is ammonia, right? Water is neutral, ethanol is neutral, and definitely acid will not be, because acid can coagulate latex instead. So only an alkaline substance can prevent the coagulation of latex. So the answer is donkey, aqueous ammonia. For number 20, element M is a metal with oxidation number +1 and can react with oxygen to produce a compound in the formula of M2O. So what's the possible element of M? So if it's M2O, means M must be a positively charged ion, because you require 2M to neutralize the charge of O2 minus. So therefore, we will say that it will be 2 times +1. So you must look for a +1 ion. So only sodium and silver can apparently do that. Okay, because the charge of sodium is actually Na+, and for silver also it is actually Ag+. All right, calcium cannot be the answer because calcium is Ca2+. Now some of you might be wondering, right, what about hydrogen then? Hydrogen is also H+, it's also a +1 charge. But why can't it be in this particular answer for this example over here? The answer is because, you see, they're saying that it is a metal. All right, we know that hydrogen is technically not a metal. So if it's not a metal, then it cannot be part of this answer. So therefore, the best answer here will be A, 1 and 2. Let's look at number 21. Table 1 shows the proton number of 4 elements. All right, we have W, X, Y, and Z, in which they already given you the proton number. Which of the following pair of elements form compounds that is insoluble in water? Okay, now let's take a look at the electron configuration for each first. So again, in a neutral atom, the number of protons will always be equivalent to number of electrons as well. Okay, only in a neutral atom that happens. Okay, so right now W also have 3 electrons, X has 13 electrons, Y has 6 electrons, and Z has 17 electrons. So the electron arrangement of W will be 2, 1, X will be 2, 8, 3, Y will be 2, 4, and Z will be 2, 8, and 7. Okay, so among all of this, which can form a compound that's insoluble in water, it could be a covalent compound. All right, because we know that ionic compounds tend to dissolve in water very well. So we're going to look out for a covalent compound, okay? So the answer here is supposed to be D, Y, and Z, because you see here, Y technically corresponds to carbon in the periodic table, and the Z is corresponding to chlorine. And since they are both non-metals, they can combine together to form a covalent compound. In fact, if you were to use this in real life, as in like carbonate chlorine can form a particular compound called tetrachloromethane, which is technically a covalent substance. And we know that covalent substance can technically definitely not dissolve in water, okay? Whereas W and X, they are actually both metals. So they are both metals, means if they combine with, say, for example, Z, then they'll be able to form ionic compound instead. And ionic compound, like I said, is usually soluble in water. All right, for that particular reason, we're going to assume that the answer is D. Okay, now, of course, if you're wondering, how can I make sure that Y is carbon or Z is chlorine, for example? How do I confirm the fact? Now, remember that you'll be given a copy of the periodic table, so you can utilize that and check and see the information that you need. The periodic table is your best friend, all right? So take a look at the periodic table. You will realize that Y corresponds to carbon and Z actually corresponds to chlorine. So that, the answer is donkey. For number 22, the following equation represents the reaction between excess zinc powder and hydrochloric acid, how the production of hydrogen can be increased. To increase the production of hydrogen, you need to make sure that you must have extra hydrogen ions, okay? Because you see here, the only thing that can form hydrogen over here is technically from the acid, okay? And of course, it is the hydrogen ion, okay? The answer is very simple, because you see, the hydrogen ion will have to combine together, okay, to form H2. That's the main idea. All right. So when you have the acid releasing, the only hydrogen you can get from the acid itself, right? So therefore, I would say the answer here is C. If you were to increase the volume of hydrochloric acid, definitely you will have more hydrogen ions. And if there are more hydrogen ions, then the hydrogen ions can technically combine together to form more hydrogen gas. While the rest of it will technically not increase the amount of hydrogen gas. So you see A here says increase the size of zinc. That actually lowers down the rate of reaction, but it doesn't actually increase or decrease the hydrogen gas. Same goes for B. Increasing volume of water will just dilute the solution. It will reduce the rate of reaction, but it will not increase or decrease the amount of gas produced. And same thing goes for D. If you increase temperature of hydrochloric acid, the rate of reaction may increase, but the volume of hydrogen gas will still be the same, because the amount of reactants remain the same. So the best answer here to describe that situation, how to increase the amount of gas being produced, is actually C. 23, the following equation shows the ionic equation for the reaction between zinc and copper to nitrate based on the equation which substance undergo oxidation. So there are many definitions of oxidation and reduction. All right. One way to see this is the gain of oxidation number or the loss of electrons. And in this case, based on this ionic equation, we can technically see one very obvious thing, right? Before the reaction, zinc is 0. All right, it has a 0 oxidation state. And then after the reaction, it becomes a +2, which is technically an increase in terms of oxidation number. So if from 0 becomes +2, then must be undergoing oxidation process, isn't it? All right. So therefore, I will say here the answer will be zinc, A. All right. All right, 24. Diagram 6 shows the energy profile diagram for the reaction between P and Q. All right, P plus Q, you get R plus S, and delta H value is X kilojoules per mole. Then they're asking you here to calculate the value of X. So the value of X is very simple. If you see the energy profile diagram, just draw a straight line across here. All right, and technically speaking, this will be your delta H. Okay, and remember, this is actually an endothermic reaction. How do I know? Because you can see here, the product has more energy than the reactants. The product is here, the reactant is here. Okay, so therefore, definitely an endothermic reaction. So what you need to do is very simple. Just take 180 minus 80 kilojoules. So you technically get 100 kilojoule per mole as your delta H. But remember, it's a positive 100 because it is an endothermic reaction. Okay, this part here, deduct this part here, then you get the answer already. Done. Let's go to 25. The following information is about type of drug. It relieves pain, it is acidic, and it may cause stomach ulcer in children. So this is very obviously referring to aspirin, okay? Because first of all, it relieves pain. All right, and then secondly, it is acidic. We know that aspirin has an acidic carboxyl group, right? It has a carboxyl group, which is technically acidic. And we know that aspirin can actually be bad for children also, especially children of very young age. Cannot give them aspirin. So 25 here is technically D. 26, diagram 7 shows the structural formula of compounds synthesized by green plant during photosynthesis. All right, there's technically only two things that's produced by green plants, okay, during photosynthesis. It's either oxygen gas or glucose, because glucose is being produced. Now, of course, this is actually glucose lah, okay? Glucose has a formula of C6H12O6. So it's asking you, what is the simplest ratio of the elements, carbon, hydrogen, oxygen for the compound? Okay, so since I give you the molecular formula of glucose already, which is C6H12O6, we're going to divide all by 6, and your empirical formula will technically be CH2O. So the ratio of carbon to hydrogen to oxygen will be 1, 2, and 1. The answer is boron. 27, the formula of ion for element X and Y are shown as follows. So you can see that X is 3 plus while Y is 2 minus, okay? So if X is 3 plus and Y is 2 minus, the compound that will be formed is very easy. You just cross the number, okay? 3 give to Y and, 3 give to Y and 2 give to X. So the formula of the compound will be X 2, Y 3 technically, all right? So this 2 is out. However, must remember that this is a 2 minus, okay? Supposedly, imagine that, Y is supposed to be an oxygen molecule. So then you must understand that if you want to react it with X, want to react with Y, it must be Y2, okay? Because it is a diatomic molecule. So X plus Y2 to get X2, Y3, just to balance the chemical equation up. And then you will notice that it is actually 4 and 3. Okay, and then you put a 2 over here to balance everything out. If you can balance this correctly, you will know that the answer is actually boron. Remember that, oxygen, for example, when they react with any elements, oxygen in its natural state is a gas, a diatomic gas to be exact. So that's your answer lah, technically. 27 is boron. For 28, diagram 8 shows an observation when the cockle shell is put into a beaker containing vinegar. The bubbles of gas is produced inside ethanoic acid. So what is X? So usually in the shell of shellfish or any seafood, it contains calcium carbonate, right? So calcium carbonate reacts with ethanoic acid, which is technically CH3COOH. Then what will happen is it will form a salt, of course, which is calcium ethanoate, and also water and carbon dioxide. So the only gas that's present over here will technically be the carbon dioxide gas, according to this equation you see. So therefore, the answer is D. All right, let's go on to 29. 29 shows the preparation of lead-2 chloride. So we have 50 cm cube of 1.0 mole per dm cube of lead-2 nitrate and 50 cm cube of sodium chloride solution to get a white color precipitate. It's asking you, what is the concentration of sodium chloride solution needed to react completely with lead 2 nitrate solution. So very easy. Let's write the chemical equation first. In any situation for questions like this, writing the chemical equation will give you a clearer picture. Right, so now we have lead nitrate reacting with 2 moles of sodium chloride to give you lead chloride, and also 2 moles of sodium nitrate. Okay, now the first thing to do is to calculate the number of mole of lead nitrate, because that's the only information that's given in full. So you can actually use the formula of MV over 1000, right? So for the MV of 1000 over here, that will be 1 multiplied by 50 divided by 1000. Okay, because you see here, it is 1 mole per dm cube and 50 cm cube of lead nitrate. So if you were to write that correctly, your number of mole here is supposed to be 0.05 mole. Okay, now this is a 1:2 ratio substance, isn't it? So if you have 0.05, then this one will be technically 0.10. Why? Because it's double the amount, right? It's a 1:2 ratio. So if you have 0.05, you must have 0.1 over here, 1:2 ratio. So now that you know the number of mole of sodium chloride, just rewrite this again. Okay, number of mole of sodium chloride will be 0.05 times 2, which will give you 0.1 mole of sodium chloride. Now that you know the number of mole and you get the volume of the sodium chloride given over here in this question, then you can use the formula to calculate the molarity or the concentration of the solution. All right, concentration or molarity is equivalent to number of mole divided by volume, but the volume must be in decimeter cube. So right now what we have is volume at cm cube. So you just take 50 divided by 1000. So that would be 0.05 decimeter cube of sodium chloride solution. And what we're going to do is that we're going to use the number of mole. So that'd be 0.10 mole divided by, what was that now? That was exactly 0.05. 0.05 decimeter cube. And in the end, what you'll get is basically 2.0 mole per decimeter cube, right? So this is the overall calculation in summary. And the answer here will be D, okay? So just use the formula of MV of 1000 to find the number of mole, and then after that, use this formula to calculate the concentration of the solution. Let's move on to 30. For number 30, a chef wants to win MasterChef competition by preparing the durian puff in the shortest time. To solve the problem, he had to make changes in the preparation of food. Choose the correct change to solve the problem. So if he wants to win it in the shortest time, he must cook the food as fast as possible, all right, thereby increasing rate of reaction. So we have to think about what are the factors which can actually increase the rate of reaction in this case. Okay, there's only 2 that can do that, right? Adding water on the outside will not help. Add more durian filling will not help also, because this will slow down the cooking process, right? You want it to heat up faster, not make it harder to heat up. So A and B will cause the heating up process to be slightly harder. What about smaller size of durian puff or higher temperature of the oven? Now, among these 2, right, these 2 can actually sort of like increase the rate of reaction. However, I would prefer to use a smaller size of durian puff. Why? Because we are going to make sure that the durian puff is cooked equally, is evenly among all the durian puff. If you increase a higher temperature in the oven, you may burn the pastry. I mean, this is technically chemistry as well as a little bit of culinary lesson, you know, in a way. So if you guys bake, or if you guys have seen people bake before, they never actually use a very high temperature, because that will technically burn the pastry, but the fillings inside will still probably be not cooked yet, you know. So instead of putting a high temperature, which can cook the food faster, but also there's a risk of burning it, we can actually decrease the size of the durian puff so they can cook faster. All right, much more manageable, I would say, compared to the one in the bottom over here. So therefore, small in size will increase the rate of reaction. Answer is C. For 31, 0.2 mole of zinc powder react with excess dilute nitric acid. After 5 minutes, 0.05 mole of zinc remains as a residue. So what is the average rate of reaction for the reaction? Number one, let's take a look at the number of mole of zinc powder that's reacted. Initially, you got 0.2 mole of zinc powder. After that, you will have a leftover of 0.05 mole. So the total number of mole of zinc reacted will be 0.2 minus 0.05, which will give you 0.15 mole of zinc that is reacted, okay? But I'm going to calculate it in terms of grams per minute. So what I'm going to do is that I'm going to calculate the mass of zinc. So mass of zinc reacted will technically be 0.15 mole multiplied by 65. Okay, and that will technically give you 9.75 grams. Okay, now that you have your mass, you can then calculate the rate of reaction by dividing it by 5 minutes. So I will say here average rate of reaction is equivalent to 7.95 grams divided by 5 minutes. So your rate of reaction here, your average rate of reaction here should be 1.95 grams per minute. So the answer here will be boiled, okay? B, 1.95 grams per minute as an overall. Okay, let's move on to 32. Basley's leg was sprained while loosening the soil in his farm. Basley asked his son to take substance X from the store and mix it into a plastic bag containing water. His son shook the plastic bag and pressed it into the injured part. What is substance X? So I think if you guys play sports, you will know that if you were to sprain your ankle or if you were to sprain your leg, for example, then you will need a ice pack or a cold pack technically, right? So you are trying to create what we call as an endothermic reaction, right? To chill the part of the leg that was swollen or that is sprained technically. So among all these substances, very simple, just remember, if you dissolve any ammonium salt in water, you will create an endothermic effect. So therefore, the answer here will be A. Ammonium nitrate dissolved in water will give you an endothermic reaction generally. So the next one, number 33, which of the following is not a hydrocarbon compound? Hydrocarbons are made up of entirely only hydrogen and carbon atoms, okay? But you can see over here, only 3 substances are made up of hydrocarbon, but they want not a hydrocarbon. Remember, look pretty carefully, not a hydrocarbon. Alkanes, hydrocarbon. Alkenes, hydrocarbon. Alkyne, hydrocarbon. Only alcohol here is not a hydrocarbon because alcohol contains the hydroxyl group. And the hydroxyl group already show you that it has an oxygen atom inside. So technically, it cannot be in hydrocarbon. So the answer for 33 will be technically donkey. For 34, diagram 10 shows the structural formula of a monomer. Which of the following is a structural formula for the polymer form? Okay, polymer for addition reaction, addition polymerization must happen between carbon-carbon double bonds. Okay, I know there's an extra group that's sticking out over here, but it doesn't matter. How you can redraw this structure is very simple. Take this structure and redraw it into something like this. Okay, we want to make the double bond, the carbon-carbon double bond, having no obstruction so that we can see things more clearly. Okay, so by reshuffling the, what's it called? The different bonds inside this particular compound, you can technically see that what I redraw over here is the same thing, except for the fact that I condense this structure into CH3 and I actually branch it up to the top. That's it. I can just move it to the top. And then now what I have is my double bond, my carbon-carbon double bond is actually not affected during polymerization process. So what happens is that during polymerization process, this carbon-carbon double bond can open up its double bond and accommodate adjacent molecules of the same type. Then after that, they will form a very long chain of polymer. That's it. So therefore, if you see properly, the same structure is actually C. So the answer here will technically be C lah for number 34. For 35, diagram 11 shows the bond formed in and between water molecules, and they're showing you the dotted lines for X bond, or James Bond, X bond. So what is bond X? So bond X is technically what we call as hydrogen bond. Okay, remember, how is hydrogen bond? How is hydrogen bond formed? Hydrogen bond is formed when hydrogen from one molecule is very close to another molecule with a fluorine atom or an oxygen atom or a nitrogen atom. Okay, so it's either H2F, H2O, or H2N. As you can see over here in the water molecule, H and O can form hydrogen bond, H and O can form hydrogen bond. If it's not that among these three, then it'll be van der Waals forces technically. All right, so that will be technically hydrogen bonding. 36, diagram 12 shows a structural formula for a compound that is used in artificial banana flavoring. All right, whenever you see the word flavoring, means you know for sure we are referring to an ester lah. Okay, so this whole structure is actually an ester compound. So what are the reactants used to produce this compound? Okay, they want a combination of acid and also alcohol that makes up this particular ester. So you must know where to draw the line lah. I would say here is where you draw the line. So this section over here is for the carboxylic acid. Okay, it's indicated by the double bond to O over here. And then this side over here will technically be the alcohol section. For the naming of esters, we name the alcohol first, followed by the carboxylic acid. So this one will have 5 carbon atom alcohol. So we shall call this as pentanol or pentan 1 all you want. And this is a 4 carbon carboxylic acid. So this will be a butanoic acid. So the two reactants that makes up this particular ester will be butanoic acid as well as pentanol. So the answer here will be C as the answer. Right, very simple. Let's look at this next one, 37. Siti immersed a piece of filter paper into a beaker containing solution P. Then she used solution Q to write chemistry on the filter paper after the paper was dried. Right, the wording on the filter paper is yellow in color. So which of the following pair is solution P and solution Q? So what she did was, she actually put P and Q together, and somehow after the word appear already, it turns yellow in color. So they want to know, is there any salt, any combination of salt that can actually be yellow in color? Yellow color precipitate technically. Why? You know why is it a precipitate? Because they say here, they want to write a chemistry word on top of filter paper. And after it dry already, right, you're supposed to see any salt crystals that's formed on the filter paper itself. All right, and this salt must be yellow in color. So among all of this combination, I would say, like, you know, if you take sodium iodide, silver nitrate, and whatever combination that you see in this A, B, C, D, the only possible answer here will technically be boy. Why? Because when you add sodium iodide and lead to nitrate, you will create an insoluble salt of lead iodide, which is technically yellow in color. All right, it's actually an insoluble salt which is yellow in color, and that's what they want, right? They say that it is a yellow color substance that forms on a piece of filter paper. So the answer here will be B. Next question, 38. Table 2 shows the observation for an experiment to investigate the effect of metals on the rusting of iron. Okay, so in this case over here now, very simple. We have P, test tube P, in which the nail is coiled with metal X and a pink spot is formed. And for Q, the iron nail is coiled with metal Y, and the blue spot is formed. Okay, so we have to ask ourselves and see which one is actually more reactive or less reactive. Like, they want you to actually arrange the three different metals. Okay, based on your observation, arrange iron, metal X, and metal Y in ascending order of electropositivity. Meaning to say from least reactive to the most reactive lah, in this case. So since you see, right, Y, if you wrap it up around iron, it forms a blue spot, which is a positive indication of iron 3 ion, okay, or rust particles technically. So Y cannot protect iron from rusting. So if Y cannot protect iron from rusting, it should be less reactive or less electropositive compared to iron itself. So Y will be the least reactive over here. Okay, Y will be the least reactive. And then after you see, right, between iron nail and X, you know, iron nail coiled around X does not rust. That's why it remains pink. So what happens here is, technically speaking, metal X has act as a sacrificial metal, and it is more electropositive, so it readily releases the electrons instead of iron. Okay, again, one more time. X is actually more reactive or more electropositive than iron, so it can act as a sacrificial metal to release electrons on behalf of iron, so iron doesn't have to get rusted. So I would say the sequence from the least reactive to the most reactive, or the least electropositive to the most electropositive, will be iron in between of X and Y, but Y is the least reactive, followed by iron and then X. So the best answer here will be boron. Number 39. Number 39 is a typo. There's a correction over here. You see, they say here, diagram 13 shows two processes that's actually involving compound W, but here they put compound V. So I actually imagine this and this is supposed to be the same thing. All right, so this, remember, technically is W. So compound W undergoes process number 1 to produce compound U, and it decolorizes the bromine water. And also, it can produce carbon dioxide under combustion to produce carbon dioxide and water. So since, I'm going to tell you what happened. So supposedly, if you can decolorize the bromine water, it is most likely an alkene. To confirm that further, combustion of alkene does actually produce carbon dioxide and water as well. So therefore, compound U is supposed to be an alkene. Okay? And just to, since compound U is alkene, process 1 is supposed to be dehydration, supposedly, which technically means that W or V over here should be an alcohol. All right? To further confirm my theory, you see that after it undergoes process number 2, compound V has a carboxyl group, which technically tells you that compound V is a carboxylic acid. So a process that can convert something to carboxylic acid is technically an alcohol. All right, so that will further confirm that my point that compound W or V is actually an alcohol, because alcohol can undergo oxidation process to produce a carboxylic acid, right, using a strong oxidizing agent. And you can see here, it also has a strong vinegar smell. So that's definitely a carboxylic acid already lah. Okay. So based on this, which structural formula represents compound W or V? It must be an alcohol. So among all this structure, it is not this one because there's alkene. It's not this one because it's alkane. It's not this one also because it's a carboxylic acid. But D is the answer because it contains a hydroxyl group, which gives you a positive indication that it is actually an alcohol. All right, let's go to our last question, number 40. Diagram 14 shows the energy level diagram for the reaction between 50 cm cube of 0.2 mole per dm cube of copper 2 nitrate solution with excess metal T. They give you the information where specific heat capacity of solution is 4.2 joules per gram per degree Celsius. All right. So what happens here is that they want you to calculate the temperature change of the reaction. So what is temperature change? You only have two formula in thermochem. All right, one is Q is equivalent to MC theta, and then the other one will be delta H is equivalent to Q over N, where the temperature change that they want actually is referring to theta. So what we're going to do is that we are going to work this in reverse. They have given you delta H value. We're going to trace it back to find Q, and then only use Q to get back the theta. Very simple. Okay, now let's start with the first equation. So the first equation we're going to use, the first formula we're going to use is this one. All right, delta H is equivalent to Q over N, because our subject now is to look for Q instead. So we have delta H, which is 220 kilojoules, and the number of moles. We have to find what N is. N is number of moles. So if you want to find number of moles, we can look at the picture, the question over here. It says here 50 cm cube or 0.2 mole per dm cube of copper nitrate solution is reacted with metal T, isn't it? So by using the let's see, number of mole of CuNO3 will be MV over 1000. All right. So this time we saw it will be 0.2 mole per dm cube multiplied by 50 cm cube divided by 1000. You'll get 0.01 mole of copper nitrate. So that'll be your number of mole. So right now what happens is, if we see properly, right, we have the number of mole N already, and we also have delta H over here, right? So we can get Q already. So Q is equivalent to delta H multiplied by N, right? You just move the N to the other side. So Q is equivalent to delta H multiplied by N. So that would be 220 multiplied by 0.01, and that should give you 2.2 kilojoules. Now, before you use Q on the first formula over here, you want to convert it back to joules first. So that will be 2,200 joules, right? Let's multiply by 1,000. Okay, after we get Q already, then we have to find out what theta is. So since Q is equal to MC theta, Q is equivalent to MC theta. To get theta, we get the subject, it will be Q divided by MC. Okay, we got Q already, no problem. We also have C already. Why? Because C is this one. Specific capacity of water is a constant. What we don't have now will be M. But M corresponds to the mass of the solution. We saw this now, right? Assuming that the density of water is, or density of solution is 1 gram per cm cube. So if we have 50 cm cube of solution, it will be equivalent to 50 grams. Just convert it into grams, that's it. All right, density of water is technically 1 gram per cm cube. So for every 1 cm cube of solution, it should be 1 gram. So 50 cm cube, 50 grams in total. So your M is now 50, very easy. So theta now, we just have to substitute the value in 2200 joules. Okay, or let's put that 2200 divided by M, which is 50, multiplied by the specific capacity of water, which is 4.2, given over here. And then let's see how much theta is. If you calculate everything correctly, you're supposed to get around 10.48 degrees Celsius, but that's not part of the answer. You can just run it off to the nearest answer here, which is technically 10.5 degrees Celsius. So therefore, the answer here will be D. Right? So that's the end of the question paper. I hope you guys have learned something from this Selangor trial paper for 2021, and also be able to do some revision before your exam is coming. So that's all for me today. Thank you for watching, and I'll see you guys in the next video.